Oh, goodness gracious. Here we go. Hopefully you guys could hear me. Okay, I can see these controls on this big computer. I'm using my desktop computer at school. Hopefully it sounds great. And I have my new webcam. Yay! I get excited over the weirdest things. Today we're going to do new module, representing relations. You need to read this, okay? You have to read this. I'm going to pause it right now for you to read it. Read it. Oh my goodness gracious. I hope that you got all this written down. So after you read it, hopefully you realize that relation's an important word, domain's an important word, range is an important word. So in a relation is a set of ordered pairs. You have to have that memorized. You have to know what that is. The first set of numbers is the domain. The domain is also our x values. Okay, so over here, we'll domain, x values. Our range is the y values. A relation is a set of ordered pairs. Now, when I'm looking at my ordered pairs, if I have it set up as, this is my independent variable, which is what your domain is, I'm choosing 1, 2, 3, or 4, and then the results are your ranges, which is your dependent variable. That's important to realize, okay? So understand your independent variable is your domain, it's your x values, it has a choice. Your dependent variable is your range or your y values. Now there's different ways we could show these relations. There's 4 different ways we get a relationship that you'll learn about right now. Way 1. Way 1 is through a mapping diagram. Where here's my domain, here's my range, with our little line, so 3 goes with 5, -4 goes with -2, 0 goes with 2. That's way 1. It's called a mapping diagram. Way 2 is a table, or a table chart. Here's my x values, here are my y values. 3 goes with 5, -4 goes with -2, 0 goes with 2. Isn't that fun? And then way 3 is the graph. I could go 3, 5, 1, 2, 3, and always, always, always write down your units, okay, guys? You have to have at least one of the units written down. That way I know what your unit is or what your scale of that map is. So I have 3 and 5, which is a location here, 3 and 5. I have -4 and -2. It's -2, this is -4. And then I have 0, -2. And always label your, 0, +2. Always label your ordered pairs. Okay? All right, so now it's way 3. Now way 4 is just your simple basic equation. So that would be the equation of a line, which we'll teach you how to do later, but not right now. All right? This is a lot of information, so make sure you have this understood, memorized, and everything written out. I write, you write. Turn the page. Okay, I already wrote on this. Okay, there's different representations of a relation. Let me hide this for you so you can't see it and you're surprised. Okay. Oh, you can't see it anyways. Sorry. Silly duck. Okay. This has got to be just like a hysterical laughter for you guys sometimes when I'm watching me make these videos. All right. Representations of a relation. So first thing I like to do is I like to write my x's and y's on top. I mean, you'll figure it out fast enough. So it says part A, express the relation as a table, a graph, and mapping. So right now, knowing that this is x, that's y, that's x, this is our relation, right? I want you to write in, fill in the blanks here for what a table looks like, a graph looks like, and mapping looks like. Press pause. Poof! Look at that. It's right there. Okay. So I'm writing my table. It's going to be 2, 0, 3, -3. 2, 0, 3, -3. And write it in that kind of order that you see it, order of appearance. 2 goes with 0, so 2 has to be lined up next to 0. 0 goes with 4, 3 goes with -5, -3 goes with -5. You can't swap out partners. It's got to be exactly as is, okay? If you have little lines there, that's fine. Make sure you have that set up like that, okay? When you do the graph, I want to reiterate a couple of things. First of all, our graph has 4 quadrants. Quadrant 1, Quadrant 2, Quadrant 3, Quadrant 4. It goes in reverse order, counterclockwise. These are our x values. This is our x. You must always label x and y, even if it's already labeled. Just make sure it's always labeled x and y. These are our independent. These are dependent values. This is also our domain. This is our range. Okay? X values are positive over here. They're negative over here. They're positive going up, negative going down. All right? So then you put the ordered pairs down there. 2, 0, x is 2, and I think Mrs. Keys would say you have to run before you can jump. So 2's there, 0's there. Then I have 0, 4. Then I have 3, I have 3 and negative 5. Sorry, this is negative 3, negative 5, and then out of order, and then negative, I have 3 and negative 5 over here. Sorry, 3, negative 5, and then negative 3, negative 5. Notice I have the ordered pairs labeled. Make sure you have it labeled as well. Here's our mapping diagram. Just write them down and just draw the arrows. Okay? Now, you do part B. Determine the domain and range of the relation. I'm going to press pause. And I'm not the neatest of writers, so I am cheating and using the answer key. Let's see if it's right. The domain is, okay. We had to do part, oh sorry, I had to do this part over here. So list the ordered pairs in each relation, negative 1, negative 5, 4, 7, negative 2, negative 3. With the table, the ordered pairs are negative 2, 3, negative 1, negative 5, and 4. So that's really out of order. So there's a negative 1, negative 5, 4, 7. Okay, that's goofy. With the graph, they just pulled ordered pairs off of there. So I have negative 2, negative 4, 1, 2, 3, 4. Then I have negative 1. Oh, that doesn't seem right. Negative 2, negative 4, 1, 2, 1, 2, 3. Oh, yeah, I can't see it. Sorry. Negative 1, positive 3, 1, 2, 3, and 5, 1. 1, 2, 3, 4, 5, 1. Yep. And mapping, I have 1 to, oh God, why not go in order, big dummies? Negative 6 to negative 1, 5 to negative 1, and 1 to 5. Okay, that looks good. I agree with their answers. Okay, I need you guys to read and annotate this next section. So go ahead and read it really quick, or slow. Just read it, and thoroughly. Okay, when you're looking at this graph, here are my days. Days are essentially the horizontal, this is the horizontal unit, right? It's horizontal. This is my x value. This is my y value. This is my independent value. This is my dependent value, okay? I could choose the number of days. There's a choice. Y is along for the right. They have no choice. Whatever x does, y's got to follow, right? Y is 100% dependent on this. So y can't happen without the x. X is like, oh, I'll be at 5 days. How long will I drive for? 5 days. This is where I'm at for 5 days, okay? So you have to be able to know how to read a graph. These are the difference of days. This is days. And almost always, time will be on your horizontal axis. Not always, almost always. That I found, at least for Algebra 1 textbooks. How about that? So, and when you read it, it's like this. Okay, so I'm driving along in my car, so days are going by. Then there's a period of time where time is going on, but am I driving at all? No driving. Driving time is increased. Driving time is increased. Driving time is increased. Is my driving time increased? Nope. Who knows what I'm doing? Maybe I'm stopping for a McDonald's. Don't know, right? Along McDonald's, at a hotel. Up, increase, and goes up all the way along. So that's how you read that graph. A couple of key things that are really important out of this paragraph. You have the independent variable, which we know is our x. Subject to choice. We could choose. The x's get to choose. The dependent variable is the y. Okay? And it depends on x. So that's why they call it a dependent variable. So those are important things to understand about that graph. Now, the next part, analyze graphs. I want you to go through and fill in the blanks, okay, with this example, and I will show the answer in a minute. Press pause. Who am I kidding? You guys can't read that. Okay, hang on a second. So let me go ahead and show you this variable, right, these answers right here. All right, take a peek. Okay, I just can't write that neat, so I'm going to fill in the blanks with this stuff here. Okay. So they want you to identify the independent and dependent variables. You have time here, number of text messages we kind of talked about. It's really important, though, as you go through this. As they move along the graph, time is going to increase, and then it becomes a horizontal line because there's a pause. There's a break in the action, right? There's a break in the action. Then it increases again. There's another pause. So time will still go on, but oddly enough, someone's not sending text messages. So that's what it means. The text messages are flat, and then they're going up again. So that's what it means. So it remains constant or flat. It's the number of text messages have not increased. It's right there. Okay? So there's your answers right there. The average, they want you to check the independent variables for each relation here. The average price of a ticket to an amusement park is steadily increased over time. So time, again, is almost always going to be on the horizontal axis. If you know that to be the case, that means you can at least answer the time part first. and then go back and answer the other part second. Okay. Again, time part is almost always going to be independent. The other part's going to be dependent. And if you want to put pause to answer those questions, go ahead. Okay, so now, this problem right here, we have to, dealing with these airplanes. Airplane is taking off. So after an airplane initially takes off, he's going to go hopefully up, right? Its altitude increases rapidly. Now, once it reaches its desired altitude, it flies at that level for a short period of time. Now, it's not exactly at that level, but it's going to, we'll just call it for all intents and purposes, it's going to be flying at a very consistent flight height, altitude, okay? Now, then, all of a sudden, it's going to fluctuate because, you know, you're going to Florida, it's really, really bumpy, and there's going to be some turbulence, okay? So there's going to be some fluctuation and there's some turbulence. That means you're going to go up and down, up and down, up and down. You know, boom, 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 you know, bam, 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 okay? So then, finally, the altitude decreases quickly, so he's going down quickly, and then the plane lands. Hopefully he's not crashing, but okay? Plane lands. So go through those different scenarios and see which one is the best choice. So now, if you take a look at it, the airplane's increasing here, and then it kind of levels off for a little bit. Then he's got bumpy, 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 bumpy. Then all of a sudden he's going to go down. Okay, so that is how it's clearly not going to be that one. I don't know what this is. It might almost be this one, but I would say I am barfing on this one. And by the way, that is going to be the phrase that pays, barfing on a plane. Not snakes on a plane or barfing on a plane. If that is my flight, I am going to be barfing. Okay, it's disgusting. Sorry about that. All right. So go ahead and do the next problem. All right, so if I'm looking at this, the traffic is kind of steady. Okay. And then it's going up. Then it's kind of steady. Then it's going down. And it's going back up again. So it wants to know what the... And I don't have... Mine doesn't have orange, so I just made it yellow. So I'd say he's going down at a steady rate for this one, for D. So hopefully you guys got that one right. Okay, turn the page. I lied. We're not doing any more. That's the end of part 1. End of part 1. Make sure you guys have the phrase that pays. Thank you.